Glass is a material so commonplace in our world today as to be easily overlooked or looked past. Its industrial uses include windows, bottles, and car windshields, to name but a few. The glass that concerns us in this lesson, however, is the specific sort of glass used in art making, and fine handcrafted design, and refined architectural details. This is glass usually referred to as art glass. In this lesson, you will learn the definition of glass, the properties that make it a unique art-making material, some forms of art glass and the methods for which they are typically used, how art glass is made at Bullseye, and some of the ways art glass is used in kiln forming. Glass is an amorphous material. Its molecules are not arranged in a regular specific pattern, like those of a crystalline material, but are random in their configuration. Because of its amorphous molecular configuration, glass reacts to heat differently than do other materials. Whereas a metal heated to its melting point will change almost instantly from solid to liquid, glass will go through a gradual transformation. It will go from behaving like a solid to behaving like a liquid. It is this unique characteristic of glass that allows it to be blown or to be worked in the myriad ways we call kiln forming. As it is heated, glass gradually begins to behave more and more like a liquid until, at temperatures above 2000 degrees Fahrenheit, it will flow easily with a consistency similar to honey. The temperatures at which glass is worked in a kiln are usually between 1000 and 1700 degrees. Within this range, a wide variety of effects may be achieved by using a variety of processes. Oftentimes, the working method used to create the object requires that the art glass have a particular form or shape. While some forms of glass serve many working purposes, all forms have methods for which they are commonly used. Sheet glass is most frequently used for fused panels or fused and slumped plates. Sheet glass is also a good choice when linear pattern is desired. Frits or powders are finely ground grains, often used in various casting methods like pot de verre or kiln casting. Frits and powders are also used to achieve painterly effects on two-dimensional panels. Rods and stringers are commonly worked in a flame, but may also be used directly in kiln forming methods. Billets are solid blocks of glass, most commonly used in kiln casting. While the methods of forming glass have developed over the centuries, the basic ingredients have changed little in the roughly 5,000 years that man has made glass. What you will see here is the way we make glass at the Bullseye factory in Portland, Oregon. The primary form of the glass made at Bullseye has always been sheet glass, so that is largely what we will cover in this brief tour of our factory. The basic materials of what is commonly referred to as a soda-lime glass are sand, soda, and lime. Sand, at about 65%, is the major ingredient of the glass recipe. Referred to as a glass former, it alone would be enough to make glass, but the temperature needed to turn it to glass would be over 3000 degrees Fahrenheit. To reduce the melting temperature, soda, a modifier, is added to the recipe. In Bullseye glass, soda ash represents about 15% of the batch, or final mix. A little more than 5% of the batch is made up of another glass modifier, lime, which makes the resulting glass more durable. Finally, metallic oxides are added to color the glass. Some of the more common inorganic colorants range from cobalt to make blue, chrome to make green, and manganese for purple, to the more exotic mineral colorants, like gold for deep pinks and rose colors, the rare earth erbium for pale pinks, and praseodymium, another rare earth, that creates a color which is very changeable in different light sources. All the ingredients of the glass batch are carefully weighed. Then they are mixed in barrels specially designed for the various glass types. After 2 hours of mixing, the batch is charged into furnaces. Historically, this was done by hand, one shovelful at a time. Now it is done almost entirely using water-cooled screw chargers, which are inserted directly into the natural gas furnaces. During the melting, the glass is stirred to homogenize the materials. After about 16 hours of melting, and according to the production schedule, the glass is ready to come out of the furnace. The casting crew then reviews what styles of glass are to be made. A steel shovel is inserted into the furnace, and the 2,350 degree Fahrenheit glass is removed. The glass is fairly liquid at this temperature. Glass workers, called casters, hand carry the ladle, or ladles in the case of multicolored mix, to the water-cooled steel casting table. To make sheet glass used for kiln forming, the preferred table is the double roller. The molten glass is fed through this pair of rollers. They extrude the glass on the other side as a sheet. The sheet is then hand-carried on a lightweight metal plate. It is placed at the opening of what is known as the layer. This layer, also referred to as an annealing oven, is over 100 feet long. An internal steel conveyor belt moves the glass through a series of convection chambers to cool it from about 1200 degrees to room temperature. After approximately 45 minutes, the sheets of glass emerge at the so-called cold end of the layer. Each sheet is then inspected and graded for color and other forming qualities. A second inspection involves testing the glass for compatibility. As the sheets reach the end of the layer, a small chip is cut out of every 10th one. The chips are placed on top of a piece of clear test glass. These test bars are then loaded into a kiln, heated to fusing temperatures, and cooled according to a very specific cycle. After cooling thoroughly, the fused test bars are viewed through polarized light. This light will bend in a visible and measurable way in response to any strain caused by a mismatch between the test chip and the clear base glass. Stress will show as small halos of light on the corners of the chips. Based on the amount of strain detected, a glass will be considered either compatible or incompatible. Compatible glasses may be fused together with any other Bullseye-compatible glasses. This testing method, developed at Bullseye over 30 years ago, has allowed the factory to produce hundreds of thousands of sheets of compatible glass that have been used successfully for decades by artists working in the field of kiln glass. Many of the other forms of glass made at the Bullseye factory use sheet glass as their source material or feedstock. Frits and powders, for instance, are ground from the tips and tails of the trimmed sheets. Stringers and rods are pulled from remelted sheet. Billets, on the other hand, are cast directly from the same furnaces used to ladle sheet glass. In the end, the material glass, whatever its shape or color, is only as magical as the artist, the designer, or the architect makes it. It is this that stops our eyes and engages our minds, a material in service to ideas.